Hi everyone, in this video we are going to discuss one of the important topic in the fourth module, that is different types of phase portraits. Nothing but singular points. In the question, if they ask about the singular points, just you have to write this topic, the meaning of singular points, different types of singular points with the graph. If they ask, just you go through this concept. Okay. See here, the phase portraits of some common non-linear systems is presented already discussed in the previous. So graph is nothing but from initial condition from 0 you have to draw the different graphs. Okay, for different initial conditions you have to draw the different graphs. So that is you will get the different phase portraits. Okay, here we have to use the different types of singular points, that is types of phase portraits. See here, first is type 0 system. In control system you have studied, right? Type 0 system, type 1 system, type 2 system. Okay. Type 0 system is regarding to the constant, that is Kp. Type 1 system means related to the velocity. Type 2 means acceleration. Like that you have studied, right? So no need to discuss all the theory behind type 0, type 1, type 2 systems. Just you go through the in type 0, 1, type 1, type 2, how the singular points are there. Okay. Just we are going to discuss this topic. See here, different types of singular points depends on the values of the poles. That is the roots value. We have to draw the different phase portraits with respect to the stability analysis. Okay. See here, we have taken here second order system. CFS divided by RFS means output by input y divided by u is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. This is what derivation already was studied in the control system. This is the very important derivation. Second order system, zeta condition, under damped, over damped and critically damped conditions. Okay. See here, this is your second order system transfer functions. Okay. See here, input is usually 0. Here take r is equal to 0. Then multiply here C of s is equal to this term. Okay, R of s into omega n square is 0. Right? Okay, C of s into this term is equal to 0. Just you have to take the here Laplace inverse transform here. C dot reverse is what? S square. Okay, just you have to take the Laplace inverse here. S square plus S plus constant. Okay. C x of t Laplace means x of s. X dot of t means s into x of s. X double dot of t means s square into x of s. Like that. See here, Laplace inverse apply for this. S square means 2 times differentiation, right? 2 times. Here C of s into inside all terms. So C term is there, output term C double dot 2 zeta omega n into s into C of s. Only one time differentiation of C. C dot into C, right, is equal to 0, where output here, first output is the first variable, x1 is equal to y, first variable is the output, this is x1 and this is x2 and this is x2 dot. So from this equation write x2 dot is equal to, what is x1 dot? X1 dot is equal to x2, x2 dot is equal to, from the given equation, highest degree is n is equal to 2 here. So highest degree, if it is highest degree, to that differentiation of the second variable is from the given equation. You know that already studied in the first module. Okay. So x1 dot, x2 dot are there. You know the procedure, x2 dx2 by dx1 is equal to, this is the equation, right? So here, if they consider the point at x1 is equal to 0, x2 is equal to 0, then the slope is equal to what? 0, which is indeterminate. Okay. So this point we called as singular point. So the trajectory we are going to study which are close to this singular point. To find out the singular point, which are nothing but the roots of the characteristic equation. Roots of the characteristic equation means this is the what? Denominator term, because input is 0, r of s is the input, this term is 0, the denominator term, that is characteristic equation of this, means roots of this equation we are going to find. Okay, s square plus 2 zeta omega ns plus omega n square roots. For example, they have taken s minus gamma 1, x minus gamma 2, where these two are roots of the equation. Depending upon these two roots, these 6 different types of singular points are obtained. Okay, so 6 singular points we are going to discuss with respect to the roots of the given equation. If they ask about the singular points, different types of singular points, just you have to write this concept only. This stable system with a complex roots. When you call it as a complex roots, okay, one is real and imaginary, right? Alpha is real root, imaginary term is j beta. Here minus alpha plus j beta minus alpha minus j beta means minus alpha plus or minus j beta. See, with complex roots, alpha and beta greater than 0. Then what are the roots here? Roots are the complex roots. Where they will get here? See, real number here is also minus alpha and here is also minus alpha. Okay, so here in this graph, minus means here, left side. Okay, minus alpha, right? Then one remaining imaginary terms are what here? Plus j beta and here minus j beta. Okay, here in this graph plus j beta and this is the minus j beta. This ಮೇಲ್ಗಡೆ plus ಇರುತ್ತೆ, ಕೆಳಗಡೆ minus ಇರುತ್ತೆ. See here, draw here the graph, the points here minus alpha plus j beta and minus alpha plus j beta. So these two roots are exist left side of the graph. Left side of the graph, if the roots are exist, we can say that the system is stable. See, already I studied in the control system subject. Singular point is called a stable focus. Roots are present, complex roots, okay, minus plus complex roots, my real value is minus and complex roots here, imaginary value plus or minus, exist in left side. If poles roots are placed at the left side, the system is stable, remember. Hence, singular points exist here is stable focus. For this complex roots, you will get the like this graph. You have to remember. Nimdu roots ee tara bantandre ee tara graph hakbeku. Minus alpha plus or minus j beta ant enadu roots bantandre just you have to draw like this singular point graphs. Okay. Next, unstable system with complex roots. Okay, when we call that it is unstable. See, complex roots plus alpha plus or minus j beta. Okay, plus alpha plus or minus j beta. Where you will get these two roots here, plus alpha plus j beta plus alpha minus j beta. The roots are exist at the right side of the graph. Right side of the system, roots are exist means we call it is a unstable system. So for this singular points we are drawing here phase portraits, that is unstable focus. See, if roots are present plus alpha plus or minus j beta and then roots bandu andre just you have to draw this graph, right? You have to remember like this graphs. Next, when we call it is a marginal stable, the complex roots, see here, there is no real term, okay, plus or minus j beta, ಒಂದು plus ಇನ್ನೊಂದು minus j beta, only imaginary term is there, plus j beta and here minus j beta value is there, no real values. So if exist on the roots are exist on the imaginary axis, we call it is a marginally stable. So for this marginal stable, we got this type of phase portraits. So ee tara roots bandre ee tara phase portraits hakbeku. Okay, and this is the marginal focus. When we call it is a stable with the real roots. Okay, see here c1 plus c2 e raised to gamma 1t plus here e raised to gamma 2t. Okay, see here, for this type both are real roots, no imaginary term. Real roots are present at the left side, only real roots ashtu adava, left side adava. System is stable. Okay, for this type of roots you will get this type of stable node, that is phase portrait graph. Okay, either roots bandre either graph hakbeku. Next is unstable with a positive real roots. ಯಾವಾಗ ಅನ್ಸ್ಟೇಬಲ್ ಅಂತೀವಿ, ರೂಟ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಅಟ್ ದಿ ರೈಟ್ ಸೈಡ್, ಇಮ್ಯಾಜಿನರಿ ಇರಂಗಿಲ್ಲ, ಓನ್ಲಿ ರಿಯಲ್ ರೂಟ್ಸ್, ಎರಡು ರಿಯಲ್ ರೂಟ್ಸ್ ರೈಟ್ ಸೈಡ್ ಎಕ್ಸಿಸ್ಟ್ ಇತ್ತಂದ್ರೆ ಪ್ಲಸ್ ಎರಡು ಬೋತ್ ಆರ್ ಪ್ಲಸ್ ವ್ಯಾಲ್ಯೂ ಮೀನ್ಸ್ ಹಿಯರ್ ಓನ್ಲಿ. ಸೊ ಇಫ್ ಬೋತ್ ಆರ್ ಅಟ್ ದಿ ರೈಟ್ ಸೈಡ್ ಎಕ್ಸಿಸ್ಟ್, ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಈಸ್ ಅ ಅನ್ಸ್ಟೇಬಲ್ ಸಿಸ್ಟಮ್. ರಿಯಲ್ ರೂಟ್ಸ್ ಅಷ್ಟಿದ್ದಾಗ ಈ ತರ ರಿವರ್ಸ್. ಓಕೆ, ಮೇಲ್ಗಡೆ ನೋಡಿ ಇದು ನೋಡಿ ರಿವರ್ಸ್ ಗ್ರಾಫ್. ಓಕೆ, ಸೊ ಲೈಕ್ ದಿಸ್ ಫೇಸ್ ಪೋರ್ಟ್ರೇಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡ್ರಾ ಫಾರ್ ದಿಸ್, ರೈಟ್? Unstable system. One is positive and one is negative. One value is positive and one value is negative. So like this system is there, you will get the like this graph. Singular point, that is phase trajectory, like this you will get it. Okay, that is one is positive and one is negative. This is unstable system, right? So you have to remember this type of graphs for the whatever you will get the roots in the given system. By using that roots, you have to draw the like this graph. Okay. First is what? Complex with unstable. Okay. Minus plus or minus j beta. Next plus alpha plus or minus j beta, unstable. Okay, both are negative means stable, left side. Both are positive means right side, unstable. One positive, one negative, real roots means unstable system. See here in this problem, determine the kind of singular point, okay, singularity for each of the following differential equation. Two differential equation they have given. First one y double dot y here. See, first you have to write in the phase state variables and state equations for this. First consider the first equation. Y is means x1 and this is x2 and this is x2 dot. Okay. So here x1 equal to y, x2 is equal to y dot. Therefore x1 dot is equal to x2, x1 dot is equal to x2 and y dot is equal to from the given equation. That is x2 dot from the given equation. So x1 dot is equal to x2, x2 dot is equal to from the given equation. dx2 by dx1 we will get this equation, right? That is slope of the equation. See, singular points means what you have to do? Singular points in the remember. Whatever the given equation is there, find the roots of this equation. Here y dot, y double dot. Okay, Laplace must you have to apply here. Sir, Laplace y of s into y of s and s square into y of s. Y of s common category s square plus 3s plus 2. Okay, so this is your equation. S square plus 3s plus 2 is equal to 0. Roots of this equation s plus 1 and s plus 2. S is equal to minus 1 and minus 2. So see here minus 1 and minus 2, these two roots are what? Negative. Where you will get in the graph? Left side. Okay. Both are negative means in the graph you have to write here negative side. Okay. So negative means this system is stable. Roots are exist in the left side means stable system. For this type of roots you have to draw the phase portrait like this. See the theory part. Both are negative real roots. You will get like this graph. Okay. You have to draw the ಎರಡು ವ್ಯಾಲ್ಯೂ ನೆಗೆಟಿವ್ ಬಂದ್ರೆ ಈ ತರ ಗ್ರಾಫ್ ಹಾಕಬೇಕು ರಿಯಲ್ ರೂಟ್ಸ್ ಆರ್ ನೆಗೆಟಿವ್ ಓಕೆ ನೆಕ್ಸ್ಟ್ second equation here they have given like this equation see here the above equation can be rewritten as like this so here similarly you go to the second equation also you will get minus 2 and plus 2 roots okay one root is minus and one root is plus okay minus 7 is left side plus 2 is right side so it is the unstable that is a saddle point you will get see the theory one is positive one is negative means you will get like this graph okay that is phase portrait like the saddle point you will get it yes